Hello everyone. Welcome to E-Learning, the official digital learning platform powered by Malla Reddy University. Myself, Ms. M. Shailaja, Assistant Professor in the Department of Data Science, School of Engineering at Malla Reddy University. As we often say, AI is the brain and data is the fuel. Then data science? It's the engine behind every smart decision powered by data. Almost every real-world challenge today, from prediction to personalization, is being solved using AI. From data to decisions, AI serves as the bridge. So this session is titled Unveiling AI, Brains Behind the Modern Data Science. This helps all the beginner learners who often hear and get confused about the essential buzzwords that define the world of AI, but may not fully understand yet. So before we dive into the code, tools, or models, this session lays the foundation to uncover the brains, systems, and the possibilities that will shape your tomorrow as a data science engineer. So today, in this session, we will be covering the most important milestones in your AI and data science journey. From understanding why AI matters in everyday life to exploring machine learning, deep learning, generative AI, transformers, prompt engineering, and even the emerging ethical side of AI. We'll also see the exciting career roles that you can pursue. So let's understand why AI is so crucial in today's world. AI is powering your everyday life, from unlocking your phone with face recognition to getting personalized shopping suggestions on your Amazon app. AI makes real-time decisions, whether it's self-driving car detecting a pedestrian or your Google Maps rerouting you instantly during the traffic. AI is scaling so fast that it's no longer confined to the big labs or tech giants. Startups, governments, and even educational platforms are using AI to drive the innovation. AI is revolutionizing the industries, be it healthcare, education, finance, agriculture, or even art. AI is improving its outcomes, automating the processes, and solving the problems at a large scale. Yes, it's not an optional anymore. Understanding AI is becoming a core skill, not just for data engineers, but for everyone working in the data, tech, or decision maker. So AI is not just the future, it's the present, shaping every moment around us. So what exactly is artificial intelligence? At its core, AI is about creating the thinking machines, the systems that can mimic the human intelligence, machines that can learn from data, make predictions, take human-like actions, and most importantly, make decisions just like we do. So in short, I can say AI is all about an equation. AI is equal to algorithms plus data plus decision making, all happening faster than we ever could imagine. It's not magic, it's smart math and smart computing. Now that we know what AI is, let's explore different types of AI based on how powerful and capable they are. So here are the types of AI: narrow AI, general AI, and super AI. Because AI systems are not all the same. Based on their capabilities, we classify into these three types. So we begin with narrow AI. Narrow AI is what we have today. It's designed for a specific task, like recognizing faces, recommending movies, or detecting spam mails. It's smart, but only in one area. You can think of Alexa, Siri, ChatGPT, Google Maps. They all do a specific task, but they can't switch their roles. Next type of AI is general AI. This is still theoretical. as it refers to the AI that can perform any intellectual task that a human can. Imagine a machine, that can write poetry in the morning, design an app by the noon, and cook the dinner for you at night, all with the human level intelligence. The next type of AI is super AI. This goes beyond human intelligence. It's an advanced concept where machines can outthink, outperform, and outdecide us in every domain. Of course, we are not there yet, but it's a direction the researchers are exploring with huge ethical and technical questions. So from task-specific bots to human-like intelligence, the spectrum of AI is broad and evolving fast. Now let's move from what AI is to how machines actually learn. Welcome to machine learning. Machine learning, often called ML, is the heartbeat of modern AI. Instead of programming a machine with rules, we give it the data and let it learn the rules on its own. In short, I'll put it short for you. In short, we don't teach, we train. Think of it like when you were a child, you learned to recognize the fruits by seeing them again and again. Similarly, machines learn by processing the data, identifying the patterns, and making the decisions based on what they have been trained. The real strength of machine learning is that it does not need to be programmed for every task. It adapts and improves with experience. The more data it sees, the smarter and more accurate it becomes. So ML shifts the focus from coding the logic to feeding the examples and letting the system learn on its own. But here's the point. Just like we people learn differently, machines also learn in different ways. So next, let's explore the types of machine learning. So here are the types of machine learning classified into supervised learning, unsupervised learning, and reinforcement learning. Supervised learning. Supervised learning means the machine learns from the labeled data. That is, during training, the data already comes with the correct answers. For example, if we provide the system with the pictures of cats and dogs, each image is already labeled as cat for cats and dog for dogs. The model uses these labeled examples to learn the patterns that distinguish one from the other. Once the training is done, we can give a model a new unseen picture, say a dog image without a label. The trained model will then predict the label, and in this case, it's the dog. So in short, supervised learning is like teaching with an answer key. The model sees the examples with correct answers first and then uses that knowledge to make the predictions on the new data. Now let's look at where supervised learning shows its real power. Here are the few. First, email filtering. Email filtering, this classifies emails as spam and not spam using the labeled examples. Then medical diagnosis. It predicts the diseases based on the symptoms using the historical patient records. Next is financial analysis. It predicts the stock prices or loan defaults by learning from past financial data. And then image recognition, whether it's identifying a face in a photo or detecting a tumor in a scan. So in short, whenever you have the past data with known labels, supervised learning is your go-to tool. Now let's explore the opposite case, where there are no labels. That's where unsupervised learning steps in. Here is the data which has no labels. We don't tell the machine what each input is. Instead, the system looks at the data on its own and tries to find the hidden patterns or the groups. For example, if we feed If we feed the pictures of animals without saying which is cat and which is dog, the algorithm will still notice the similarities. It might group the cats together in one cluster and dogs in another cluster. So unlike supervised learning, where we teach with an answer key, in unsupervised learning, the machine is exploring and discovering the patterns by itself. Now let's see where is unsupervised learning actually used. So here are a few exciting examples. The first, market basket analysis. Imagine shopping online. You add a bread to your cart and suddenly you see the system suggests butter or jam. That's unsupervised learning, finding the products that are often brought together, helping the e-commerce and the supermarkets place the items smartly. The next application is genetic clustering. In healthcare, scientists use this unsupervised learning to group the genes that behave in similar ways. This helps the researchers discover the disease patterns like, grouping genes that are linked to cancer and grouping the genes that are linked to diabetes. Then we have social network analysis. Think of the platforms like LinkedIn or Facebook or Instagram. The system detects the hidden communities. For example, a cluster of software engineers or a group of people passionate about photography, even though nobody explicitly labeled them. And next comes anomaly detection. Majorly banks use this every day. Let's say if your credit card suddenly shows a very unusual transaction. Say you are in Hyderabad, but someone swipes your card in New York. The system flags it as suspicious. That's unsupervised learning, spotting the outliers in your data. Now comes the most exciting and dynamic form of learning, reinforcement learning. Think of this learning as teaching through trial and error. You give the rewards for the good behavior and you give penalties for the bad behavior. Just like training a dog, when it follows a command, you reward it. When it disobeys, there is no reward. Over the time, it learns what actions leads to positive outcomes and what not. In reinforcement learning, we have an agent that will be interacting with an environment. The agent takes the actions, observes the results, and receives either rewards or penalties. Based on this feedback, it keeps improving its decisions. A classic example is self-driving cars. If the car drives smoothly and follows all the rules, it gets a reward. But if it crashes or makes unsafe moves, it gets a penalty. Over many iterations, the system learns to drive safely. So reinforcement is all about learning by doing. Reinforcement learning powers some of the smartest systems around us. Taking the video games, in video games, AI learns to win by playing over and over. Similarly, in the robotics, it helps the machines walk, grab, and act without hard coding. Next is autonomous vehicles, which use this reinforcement learning to make the real-time decisions in traffic, from where to stop, how to safely overtake another vehicle, and all. And next, for the recommendations, it learns your preferences and tailors the suggestions as per you. But what's really powering these smart decisions under the hood? The answer lies in something that is inspired by our own brains. Yes, it's about neural networks. Neural networks are inspired by our human brain. Just like our brain has neurons that pass signals, a neural network has artificial neurons. They are called as perceptrons. They process the information and pass it forward. Now, when these neurons all are connected in layers, they actually form an artificial neural network. In short, ANN. This network takes the input, processes it through hidden layers and gives the output, like recognizing a face, translating the text, or predicting a value. Let's break this down further and see how a neural network actually works, step by step. This is how, as you can see, the inputs are the data values we feed into the network. Each input is then multiplied by a weight. These are the numbers that tells how important the input is. Then a bias is added which helps the model adjust and fit the data better. Now, the total is calculated in the net input function, which is simply a weighted sum. Now, this passes through an activation function, which is the one that takes the decision if the neuron should fire, meaning whether to activate that neuron and pass the information forward or not. Finally, the output is produced and sent that output to the next layers. It's this mathematical modeled structure that enables the machines to learn the patterns, detect the signals, and make smart decisions, almost like how we think. Here's an example to understand it better. As you can see here, at the input layer where the raw data enters, the pixels of fruit images are there. Next, the data moves through the hidden layers, and this is where the network learns patterns like the color, shape, and texture of the fruit. As the information flows forward, the hidden layers keep refining these features and combining them. Finally, we reach the output layer, which gives us the prediction. And in this case, the network identifies the fruit as a green apple. So in short, input goes in, patterns are processed in the hidden layers, and a meaningful output comes out. That's how neural networks mimic the way we think, one layer at a time. Neural networks improve as they see more data. Putting it simple, the more data the network sees, the smarter and accurate its predictions become. Now that we have seen how neural networks learn and improve, let's explore what happens when we stack many of these layers. Welcome to deep learning. When we stack many layers of neurons together, we get deep learning. It is simply the neural networks with many hidden layers. These extra layers help the system understand the deeper patterns in the data, the things that the simple models cannot catch. So let's understand how deep learning sees an octopus. This image shows how a deep learning model like a neural network can recognize something like a drawing of a blue octopus. Let's break it down simply. At the input layer, the network first looks at the parts of the pictures, like color, patterns, and the shapes. Now in the hidden layers, these layers break down the input into the features. For example, here, blue color, animal face, number of legs, and each layer passes its understanding onto the next layer. Now finally, at the output layer, the network combines what it learned to figure out this is blue, it is an octopus, it's cute. And here's come the final result. All those signals come together to say this is a cute drawing of a blue octopus. So what's really happening? Deep learning helps the computers look at the details one layer at a time. Just like how we scan a photo. You check the color first, you then shape, and then what it looks like overall. That's why it's called deep, because it goes through many layers of understanding from simple to complex. And the best part, you don't need to manually tell the model what features to look for. Deep learning models learn all these automatically by training on large volumes of data. This is what makes today's AI feel almost human-like in its capabilities. Now, while traditional AI learned to predict and classify, the new revolution began. AI started to create. Welcome to generative AI. Let's now enter one of the most fascinating areas of modern AI, that is generative AI, where AI starts creating. While traditional AI analyzes the data, generative AI creates new data. It can generate text, images, music, code, and even videos, often so realistic that it's hard to tell the difference from human-made content. It learns from massive data sets and then generates the outputs that look and feel real. Whether it's writing emails, poems, or generating fresh ideas, AI can now assist in text creation. It can also write and debug the code and even analyze the entire programs, helping the developers work faster. And visually, it can generate stunning images, artistic paintings, and creative drawings, all from just a single prompt. And so generative AI is like a creative assistant helping us imagine, build, and express faster than ever before. For example, ChatGPT creates human-like conversations, DALL-E and Midjourney generate stunning images, and Music AI can compose new melodies, and OpenAI Jukebox can even compose music. Now it's time to explore the different types of generative AI models. Generative Adversarial Network, simply GANs, transformer-based models, and diffusion models. First, we start with GANs. GANs are like a creative battle between two neural networks. One is generator and the other is the discriminator. Generator tries to create fake data that looks real. Discriminator tries to detect whether the data is real or fake. These two networks keep challenging each other. At first, generator makes poor fakes, but as the game continues, both get smarter. And over the time, generator produces the outputs so realistic that the discriminator can't handle the difference. Eventually, the generator becomes so skilled that even the discriminator can't tell the difference. And thus, we get realistic images, videos, and even human-like faces. And that's the power of GANs. So here's a simple example of how a GAN works. The generator creates a fake image that looks like our own Elon Musk, but it's entirely AI generated. Then the discriminator steps in and tries to decide, is this real or fake? If it gets fooled, generator wins. If it catches the fake, generator learns and improves. This back and forth keeps happening until the fake becomes almost indistinguishable from the real. And that's the power of GANs. GANs are behind many deepfake videos, realistic image generation, and even AI-created art. But GANs are not the only way machines create images. Another powerful method that has recently become the state of the art is diffusion models. Let's see how they work. Diffusion models are one of the most powerful and recent breakthroughs in AI-generated images. They completely work different. They learn by adding and removing the noise from data. They start with the random noise and gradually generate image. They may be slow, but they generate very high quality images. So here's how they work. The model first learns to add noise to the images, basically turning them into a complete distortion. Wait, now what is noise? Noise is simply some random pixels or visual static like blurring or scrambling an image. It hides the original picture and the model is trained to remove that noise step by step until the real image is recovered. So during generation, the model starts with pure noise and slowly refines it into a clear and realistic image. As I said, the process is a little slow, but it's very stable and produces incredibly high quality results. That's why diffusion models are used in the tools like DALL-E 2, Stable Diffusion, and Midjourney. They are the ones that are creating stunning AI art today. And it doesn't stop at images. Advanced diffusion models can now generate full videos, frame by frame, with incredible realism. Tools like Runway ML, OpenAI, Sora are pushing the boundaries of what's possible in AI-generated video. Let me show you a fascinating example. A static image of Mona Lisa brought to life. Using diffusion-based video generation, the model animates her face, making Mona Lisa blink, moving her lips, and turn her head, as if the painting is alive. This shows how AI can generate realistic motion from still images, creating video-like outputs without a camera. It's creative, little airy, and a huge leap in the generative technology. While GANs and diffusion models dominate in the visual content, when it comes to language, understanding, writing, and translating, we rely on a different kind of intelligence. That's where transformers come in. Transformers, they are powering the modern AI. This deep understanding of context is what powers today's language models. They use a mechanism called self-attention, where the model doesn't just read a sentence from left to right. It looks at all the words at once and understands the relationships between them, no matter how far apart they are. For example, in the sentence, the cat sat on the mat because it was tired. Now this refers to the cat, not the mat. They are powerful because they understand the context, tone, and intent, just like how we do in conversations. That's why the models like BERT, GPT, T5, and ChatGPT are built on the transformer architecture. Transformers use a powerful architecture of encoder-decoder structure. As you can see here, the encoder takes the input text and builds a rich internal understanding, capturing the meaning, grammar, and structure. On the other hand, decoder then uses this understanding to generate a meaningful output, like a translated sentence, a summary, or a chatbot reply. This structure allows AI to handle the tasks like translation from English to French, text summarizations, and natural conversation generation. So in short, transformers are the reason AI can talk, write, translate, and even reason like never before. Now that we have explored transformers and how they process the text, let's talk about where all this is used. Natural language processing, simply NLP, and sequence modeling. Transformers are the architectures that revolutionized natural language processing. NLP is the branch of AI that deals with understanding, interpreting, and generating human language. Just like we speak, read, and write, it combines linguistics, machine learning, and deep learning to help the machines make sense of the language, whether it's a message, a question, or an entire document. NLP is what powers the chatbots like ChatGPT, language translation tools, search engines, sentiment analysis in social media, and voice assistants like Siri and Alexa. In short, NLP is the bridge between the humans and the machines, and transformers are the engines driving it. And now, let's zoom in on the powerhouse behind today's most advanced NLP tools. Yes, it's about large language models, in short, LLMs. LLMs are deep learning models that are trained on huge amounts of text data, sometimes even internet. They are designed to understand the context, structure, grammar, meaning, and then generate the language that sounds human. This image shows what LLMs are trained on and what they can do. They are trained on diverse data like text, voice, images, even 3D signals, and are adapted to perform various tasks like extracting information, following the instructions, recognizing the objects, answering the questions, and even understanding the emotions. LLMs do far more than just chat. They are becoming the intelligent digital assistants across every domain. Here's how a typical LLM agent works behind the scenes. You send a query, say a question or a task. The LLM agent picks it up and checks if it needs external data like APIs, internet, or vector databases. It then updates the query and passes it to the LLM, the brain, which processes and returns a meaningful response. Now, this response goes back through the agent and is finally delivered to you. Neat, accurate, and context aware. Now, what makes LLM special is their scale. They have billions of these parameters, which allows them to capture the subtle meanings and handle a wide range of tasks. In simple terms, you give it a word, you give it few words, it predicts what should come next, and then generates fluent, context-aware text. LLMs are the core engines behind the tools like Google Bard and Copilot, transforming the way we communicate with the machines. But here's the catch. To get best out of these powerful models, we need to know how to talk to them. And that's where prompt engineering comes in. It is all about talking to the AI the smartest way. Prompt engineering is the art of crafting the right input or the right questions, so the AI gives you exactly what you want. It's not just about asking something, it's about asking it the right way. For example, instead of writing the prompt as write code, a better prompt would be write Python code to sort a list of numbers in the ascending order. So what you understand here is better prompts, better results. And that's why prompt engineering today is becoming a key skill. Whether you are generating content, writing the code, analyzing the documents, or even building the chatbots. It's not just using AI. It's about controlling it with precision. Now let's look at some magic of the better prompts. So it's just type in what you want. Like here you can see the prompt is a cat sitting on the bed. Hit the generate and the AI brings your idea to life as an image. No drawing skills needed, just your imagination and a good prompt. Here's another interesting one. You simply describe what you want, like a pink toy horse on a beach, and AI takes over. It starts with complete noise and gradually fills in the details, pixel by pixel, until your vision becomes reality. So the clearer your prompt, the better the result. And that's why prompt engineering is a valuable skill in today's AI world. But AI is evolving beyond just generating the outputs. It's also about how it's built, where it runs, and whether we can trust it. So that's where the new emerging types of AI comes in. And you'll hear a lot about this in the future. So here are the emerging types of AI: smarter, safer, and greener. Green AI, responsible AI, edge AI, and explainable AI. Looking at edge AI means running the AI directly on the devices like phones, cameras, or sensors without needing any cloud access. And so it's faster, works offline, and keeps your data more private. You may think of it as a smart decisions made right at the source. The next is green AI. Green AI is all about making the artificial intelligence eco-friendly. Instead of building only the bigger or more power-hungry models, the focus is on the smaller, efficient models, smarter deployment strategies, and being aware of energy usage and carbon usage. So in short, green AI is about saving energy and resources while still delivering the great performance. Next is explainable AI. Explainable AI is about opening the black box. Yes, it helps us understand why a model made a certain decision, making AI more transparent and easier to trust. For example, in credit scoring, explainable AI can show why a person's loan was approved or rejected, ensuring the decisions are clear, fair, and accountable. And the next is responsible AI. Responsible AI ensures that the systems are fair, ethical, and free from bias. It's all about building the AI where we can hold accountable. Example, if you take AI in hiring, responsible AI helps remove any bias from resume screening, candidate selection, so that opportunities are ensured based on the skills and merit, not on the gender discrimination. Here's an interesting AI, emotional AI. This takes the human-computer interaction to the next level. It reads your facial expressions, your voice tone, and even the body language to sense how a person feels. This makes AI not just smart, but emotionally aware, helping in mental health, education, and personalized user experiences. We have seen how far AI can go, from solving problems to creating art, writing, music, and more. But now AI has a bigger responsibility. It's not just about algorithms or performance anymore. It's about people making the lives better. It's about the purpose, solving the right problems. And it's about the planet, building a future that is sustainable and kind. Because the real power of AI lies in how human it can truly become. It's now time to look at some career opportunities that directly connect with the topics that we have explored in this session. If you enjoyed the part of machine learning, you can aim to become a machine learning engineer who builds models that make predictions and decisions. If neural networks and deep learning fascinated you, the role of deep learning specialist or computer vision engineer could be your path, working on image recognition, speech, or autonomous systems. And for the people those are excited by generative AI, GANs, and diffusion models, there are still roles like generative AI engineer or AI content creator, designing the systems that generate images, text, and even music. If you are more connected with the transformers, LLMs, and prompt engineering, then you can pursue a career as an NLP engineer or prompt engineering, focusing on language models, chatbots, and text-based AI. And finally, if you're passionate about applying AI in the real-world data problems, the role of a data scientist or AI researcher is always in demand. So the career you choose can grow directly from the concepts of AI that we have learned today. Winding up, let's quickly shower a light on the journey we have taken in today's session. AI begins with the idea of making machines think and learn like humans. At the core, machine learning is where systems learn patterns from data to make the smart decisions. Deep learning builds on this using neural networks that mimic how our brain works, helping the machines recognize the speech, images, and more. Then generative AI takes it a step further, not just learning, but creating. With GANs, machines can generate realistic images by learning from the real ones. Diffusion models, they refine this process, starting with the noise and slowly crafting high-quality visuals, even videos. To understand and generate language, AI uses transformers powered by self-attention and encoder-decoder architectures. This led to the breakthroughs in NLP like translation, summarization, and conversation. On top of this came LLMs like GPT, Claude, and Gemini, capable of generating the content, writing code, and answering the complex questions. So to get the best from these models, we use prompt engineering, carefully designing our inputs to guide the output. So generative AI today powers everything from chatbots to artwork, videos, to voice-touching industries like media, healthcare, and education. As AI grows, so do its values, with the green AI for sustainability, responsible AI for fairness, edge AI for on-device intelligence, and explainable AI to make the systems more transparent. I would like to now conclude with the real takeaway. AI is no longer just a tool. It's becoming a partner, one that can help us solve the problems and spark creativity. As engineers, innovators, and learners, it's in your hands to shape your future with fairness, purpose, and responsibility. Thank you for joining me on this journey. Stay curious, stay consistent. Thank you once again.